Hey guys, so I'm going to be doing a combustion problem example. So the problem is calling about a fuel made out of carbon, hydrogen, and nitrogen. And we have the letters, the variables there, just because those are unknown subscripts. And then it's combustion, so it is in water. And as combustion, it yields out carbon dioxide and water. So the problem says that there is 2.859 grams of the fuel reacted with excess oxygen, and it comes out with 4.190 grams of carbon dioxide and 3.428 grams of water. So this is our given information. Now what we need to do is we need to isolate the carbon from CO2 and the hydrogen from H2O to then put them into there. And then the nitrogen we'll just find by other means. So we are going to start with the carbon in carbon dioxide. So we know that first thing we need to do is find the percent mass of carbon within carbon dioxide. So we multiply 12.011 grams, which is per mole, off of the that's just off of the periodic table, times one mole over 44.009. And the 44.009 is basically the molar mass of the carbon dioxide. So when you do that, your answer is 0.27292. And I know how I said this is the percent mass, so this does equal around 27%. But the thing is, it's easier to keep it like this for further calculations. So now you need to find 0.27292 of 4.190, which is the grams of the carbon dioxide product as after the combustion, and that gives you 1.144 grams of carbon in the carbon dioxide provided. Now we know with the law of conservation of mass that this amount of carbon, this gram amount, does not change from the fuel to the carbon dioxide. So, like I say, when in doubt, convert everything into moles. So now we have 1.144 grams of carbon, and you multiply it by 1 mole over 12.011, because that is the mass of carbon just from the periodic table, and that equals 0.09525 moles. So remember this number, it's going to play a big part later into the problem. But right now, we need to find the moles of the hydrogen. So hydrogen in water is H2, so that's what we work with initially. And H2, so we have 2.016 times 1 mole over 18.014 18.015. And the 18.015 is simply the molar mass of water as a whole. And the 2.016 is from the periodic table, it's H2 because H is only 1.008. And this is also finding the percent mass, but we're going to do the same thing where we keep it in decimal form. So it's 0.1119, and you multiply that by 3.428 grams, which is what is given in the problem, and that equals 0.3836 grams. So this is the same thing. Once you are in the grams, it's the law of conservation of mass. So this is the amount of grams of hydrogen within the entire problem. So we're going to convert it into moles because moles are basically the linking unit. You can't really work with grams when you need to find empirical. So what we're going to do is we're going to multiply 0.3836 grams, and we're going to convert it into moles, so it's 1 mole. But right now we're only working with hydrogen, not H2. So this is only going to be 1.008 from the periodic table, and that equals 0.3806 moles. So this number is important now because what we have to do is we need to find the amount of nitrogen, but we don't have any information about nitrogen from the product. So what we have to do is we have to take the total, which is 2.859 grams, this is the total amount of fuel, minus the grams of carbon, which is 1.144, plus the grams of H2, which is 0.3836. And when you do that, you have 1.3314 grams of nitrogen. Now you need to convert it into moles. So you have 1.3314 times 1 mole over 14.007, which is just from the periodic table, and that equals 0.0951 moles of nitrogen. Now this number is also important for our final step, which is what we're going to do is we're going to have carbon, hydrogen, and nitrogen. And these little lines are basically the numbers for the division to find what it's going to become. So what we do is you put the overall smallest mole amount at the bottom, which is for nitrogen 0.0951. And then you keep it on the denominator of all of them. 951.095. And then you put the mole count for each of the elements. So for carbon it's 0.0952, and for hydrogen it's 0.3806. And nitrogen it's 0.9510. So now what you do is you divide. So in the end you are going to end up with C1H4N1. And these numbers aren't exact, but basically always look for a way to get it to a half or a 0. If it is around a third, especially for our test on Thursday, then you would just know to multiply everything by 3 to then make it a 0 for the decimal place. So this is the empirical formula, and now we need to find the molecular formula. So what we are going to do is, let me just X this out. We have CH4 N, and we need to find the molecular formula of this, which is just adding everything from the periodic table, and that equals 30.05 grams. And we need to remember from the beginning of the problem, we were told that the molar mass, so molar mass, is 60.10 grams. So now you know to divide the 60.1 divided by 30.05, and that equals 2. So what you're going to do is multiply 2 by CH4N, and you're going to end up with C2H8N2. And that is the molecular formula, and that is how you solve a combustion problem. I hope that was helpful, and I'm going to submit more videos. Thanks. Have a nice night.